All right, so today we'll be learning 10.1 in 3D graphing. So basically, unlike a Cartesian plane with a single plane, it's going to be with an extra dimension, which means that there's a z-coordinate now, as you can see. So the difference between a Cartesian plane and the three-dimensional graph is when there's coordinates, it's going to have 3 instead of 2 variables. So for an example, in an xy plane, you can have 1, 2, which would be 1 in the x direction and 2 in the y direction. Thus it would be around there. You can see you went up in the x and 2 in the y, as you can see there. And if you draw, you can see that it's parallel and makes it form a little parallelogram because it's 3D. So now, if you were to take this further and add a z coordinate, as in like 1, 2, 3, as you can see there, now you would get this point. So you get 1, and you go 2, and then instead you would go 3 upwards. So 1, 2, 3 to the z, right? And in order to graph this, since it's 3-dimensional on a 2-dimensional plane, you would follow the z-axis in parallel to the x-axis, and you would stop until you reach the direction of the y, which would mean that, hold on, you can cut this out later. I forgot how to graph. So as you can see here, you go to your z, so you go 3. So you go up 1, 2, 1, 2, 3, and you go there. And in order to get to the single point that you need, you have to follow in the x direction until you become completely parallel, as you can see, to the x. So x is 1, so you're looking for this, right? So if I draw a straight line up, this is where we stop. Then after you reach that point, you go in parallel to the y direction for the specified amount of points. As in, so this is 2, so if I draw another straight line up, we'd stop, and then where they intersect, there is your point. And you can see clearly, not clearly, but if you look closely, it forms a little prism with the 4 corners, and the corner being the one that is closest to, the one that's farthest away from the origin in terms of the octant. Yes, the one that's farthest away from the origin. And in a way, this is also a way how vectors are drawn. So from going from 2.1 to 2.2, all right? So now that we're in 2.2, right? Now we're going to be learning about vectors. So take the single point that we got from 10.1, right? It was point 1, 2, 3. Now we're going to turn it into a vector, or in a way, it's a line with magnitude. So this is the direction, in a way, and it's all vectors. Vectors start from the origin. So in order to transfer this to vector form, it would be that symbol, 1, 2, 3. Okay, 3, as you can see there. As in, there would be a line now from going from the origin to that point that is specified there. However, there are some vectors that may be not from the origin, such as vector 1, 2, 3, 4, 5, 6. As you can see there, this is not a vector, since it is a vector, but it's not from the origin. So in order to get it into standard form, what you'd want to do is you'd have to subtract the initial point from the final point. I learned this in physics. Terminal point. But it's basically the final point. So basically this is where it ends, this is where it begins. So what you want to do is you want to get the initial point to become 0. The origin, so 0, 0, 0. So how do you do that? You subtract 1 from the x, subtract 2 from the y, and subtract 3 from the z. Do that to both points now, because remember, it's a single line. So in order to transfer, if you're going to subtract points from one of the points, then you'd subtract it from all of them. So once you do that, this becomes 0, 0, 0, and this becomes 3, 3, 3. Thus, you get the vector in standard form, 3, 3, 3. So now, you may be wondering, how do I find the magnitude of such a vector? And I can be able to tell you that that the magnitude of any point or line segment or vector is equal to the distance of said line. As you can see, do you notice anything similar about this shape? That's right, it's a right triangle. And how do we find the length of the hypotenuse in a right triangle? That's right, it's Pythagoras theorem, Pythagorean theorem, which means we take the y-coordinate squared plus the x-coordinate squared, the x-coordinate squared, plus the z-coordinate squared, and thus you get the distance of this, or in other cases, the magnitude. So let's graph this. This is our point. This is the point 333. So if you draw the straight line 2.333, you can get this total distance by doing the distance formula, which is derived from Pythagorean's theorem. Thus, it would be rad 3 squared plus 3 squared plus 3 squared, or 3 times 3 squared, which is 9 plus 9 plus 9, which is 36. Shut up. No, let's cut that out. Rad 27, which can be further reduced to divided by 9 to, shut up, 3.
Tell you the fucking right answer. Stop.
Oh, right. Okay. Yeah. 3 rad 3, which is going to be our magnitude of this vector. Finding the distance between 2 points, such as these 2 points we stated earlier. Now, the thing is what you'd want to do is it would be similar to how you found this one, is that you want to transform it into vector form first. Basically, it's x2 minus x1 squared plus y2 minus y1 squared plus z squared, z2 minus z1 squared, all under the square root, which is exactly what we did. We subtracted all the values and we got 3 to 3 and then squared them. And then got the square root. And that's how we found the distance. The distance of this is equal to the distance of this, because 4 minus 1 is 3, and you get the you get the deal. 10.3. We're going to be doing cross product. So let's say we have our vector here from last time. Let's label it now vector v. So as we know earlier, it was 3. Yes, thank you. 3, then 3, as you can see. Now, we're going to have another vector. It's going to be called vector u, and we're going to have it go in this direction. Let's just say it's 3, 3, negative 3, negative 3, negative 3. U equals negative 3, negative 3, negative 3. Now that we have these two vectors, we can do the cross product of them. That's the notation. It's going to be okay, u x v. So what you're going to do is you're going to convert them into ijk form. You put them into a matrix. So I at the top, then j, then k with those. Then you put what you're being multiplying. So it's u cross v. So you put u. It's going to be negative 3, negative 3, negative 3. Then you put v. So 3, 3, 3. So now that it's in a matrix, what you want to do is you're going to find the determinant. Now you can do multiple ways of finding the determinant, but I'm going to do one way. First, you want to get, obviously, the i's. So you get 9i plus these, so it's negative 3 times 3, so minus 9j. And then you get the k's, and you get, so minus 9k, and then you subtract, so plus 9k, then plus 9j, and minus 9i. And as you can see, they all cancel out, and thus your cross product is 0.
Grace Hopper was an American Rear Admiral in the United States Navy and was a computer scientist who had a great impact on the history of mathematics and computer science. She lived from December 9, 1906 to January 1, 1992. She was one of the first programmers of the Harvard Mark computer. She was also part of the team that developed the UNIVAC computer. She led to the release of the compiling language Flowmatic. She also developed COBOL, one of the first high-level programming languages. COBOL would eventually become one of the most important programming languages in the 20th century. She also invented the first compiler, a program that translates programming code to machine language. Her education included a PhD in mathematics at Yale, and she was a math professor at Vassar College. In the Navy, she was able to join despite being under the weight requirement because her contributions were deemed beneficial to the war effort at the time. She graduated top of her training class. She was the first female to be awarded the National Medal of Technology in 1991. She was awarded the Presidential Award of Freedom in 2016 by Barack Obama. She was one of the few women in a male-dominated world of math and physics at the time. Not only did she become an important figure in mathematics, but as well as a role model for women in technology as well.
Okay, so this
this is good for our bloopers.
Yeah. No, John, don't do it. Don't do it, John.
That's why I don't have friends.
z minus, it doesn't really matter, just any variable.